Hello, this is second part of segmentation. In this part, we are going to see different segment operations, exactly segment creation, segment closing a segment, deleting a segment, and renaming a segment. These are some important segmentation operations. So let's see, the first one is segment creation. We must give the segment name so that we can identify it. And suppose we want to create segment number 3, then all following move and line commands in the display file, they will belong to segment number 3. We could then close segment 3 and open another segment, and we can do this for as many segments as we want. First thing is to check whether some other segment is open. This is very important, otherwise we would get an error. We cannot open two segments at the same time. Second thing we must have a check is to see valid segment name, means the segment that we have opened is having a valid segment name, and check whether there already exists a segment name under this name. If so, we get an error. It's just like we are trying to open a new mail ID and that mail ID already exists, we get an error. On the same way, on the same grounds, here also we should have a valid segment name, already existing segment name. Now you cannot assign. The first instruction belonging to this segment will be located at the next free storage area in the display file, and the current size of the segment is 0 since we have not actually entered any instructions into it. As we go on adding more and more instructions, the size of the segment will increase, but by default at the beginning, at the time of creation of the segment, the size of the segment is 0. Okay, so this is the segment creation operation. Next is closing a segment. Is very easy. We have an open variable whose value is set to 0 and the segment will get closed. So once we have completed our drawing instructions by opening segment and making entry of the instructions, we should close it. This is the protocol. At this point, all that is necessary in closing the segment is to change the value of open variable, which indicate the name of the currently open segment. We set the value of this variable to 0. So we have an open variable which indicates the name of the currently open segment, and we simply have to change the value of this variable to 0. We don't have two unnamed segments around because we shall show only one of them and the other would just waste storage. So if there are two unnamed segments in the display file, one has to be deleted. Okay, so this is closing a segment. Again, I repeat, only the most important thing in this is the open variable whose value we have to set to 0 and the segment will get closed. Okay, next is deleting a segment. Now this is very peculiar. If the segment is no longer needed, then we delete that segment while preserving the rest of the display file. We have to keep the rest of the display file intact, though we are deleting unnecessary segment. The method of doing this depends upon the data structure used for the display file. Since we have used arrays, recovery of the block of storage is simple. Okay, and to do this, we must delete just one segment while preserving the rest of the display file intact. Here we have used arrays to store the display file information. Suppose we want to delete segment number 2 from this display file. So all the subsequent segments, namely segment 3, 4, they all have to move upwards. And how far we move them upwards is by the size of the segment that is to be deleted. That means the size of segment number 2. Okay. After doing this, the starting position of all the subsequent segments, like the starting position of segment 3, starting position of segment 4, and so on and so forth, they all have to be now adjusted. They have to be moved up. So starting position of segment 3 will now be the new position of starting position of segment 3 will be old value of starting position of segment 3 minus size of segment 2. And the same we'll have to repeat for all the later segments. So in this, we take all display file instructions entered after the segment which we are deleting which was closed and move them up in the display file so that they lie on the top of the deleted segment. Okay, so this is the scenario before deleting segment number 2, and this is the scenario after deleting segment number 2. And since we are using arrays, this is going to be easy. Now there are certain rules we must adhere to while we think of deleting a segment. Means there is a total algorithm for deleting a segment. This is we called a delete algorithm. So first of all, we read the name of the segment which is to be deleted. Okay, we have to check whether the name of the segment is valid. If not, we display error that segment is not valid, and we should go to step number 8. So check whether the segment name is valid. If not, display error message segment not valid, and we should go to step number 8. So this is the first thing we should check, that segment name is a valid segment name. Next is we check whether the segment is open. If yes, we display message can't delete an open segment. So you cannot delete an open segment, and you should go to step number 8. Third thing, important thing we should check is whether the size of the segment is greater than 0. If no, there is no point in deleting such a segment whose size is 0. There is nothing in that segment. So if no processing is required, as segment contains no instructions, and this then becomes an absolute operation. Next step is if we pass all these checks, that segment name is valid, segment is not open, size of the segment is greater than 0, means we have some instructions in the segment, then we should shift the display file elements which follow the segment which is to be deleted by its size. Just now we have seen, we have to shift all these segments upward. Recover the deleted space by resetting the index of the next free instruction. So the starting position of each of these segment has to be changed by subtracting the size of segment 2 from them, and then adjust the starting positions of the shifted segments by subtracting the size of the deleted segment from it. Just now I have explained, and then we stop. So this is the operation of deleting a segment. Now next is renaming a segment. This is the last operation, and it is finding peculiar applications in animation. Okay, so the display processor is continuously reading the display file and showing its contents. They are continuously being displayed on the display devices. In animation, what happens is, in animation, to display a new image in the sequence, we have to delete the current segment and recreate it with an altered character. Maybe the character size has increased, maybe it has translated, rotated, something has happened. So we have to recreate it with the altered character. Segment which is to be deleted and segment which is to be replaced with must exist in the display file at the same time, which is perhaps difficult. We do this by building the new invisible image under some temporary segment name. When it is completed, we delete the original image, make the replacement image visible, and rename the new segment to become the old segment to achieve apparent motion. That is what we do. So we create a temporary segment, and then we copy things from the original image to the temporary segment, and once it becomes apparent, we rename the temporary segment with the old original segment name and delete that temporary segment. This is what it happens. The idea of maintaining two images like this is called as double buffering. We may have multiple buffers in our graphic systems, no problem. Okay, so this is the algorithm to rename a segment. We first check whether both old and new segment names are valid. Both these names has to be valid. If not, it display an error message not valid segment names, and you should go to step 6 and abandon the operation. Second step is check whether any of the two segments are open. If open, you display error message segment still open, and you go to step 6. Check whether the new name we are going to give to the old segment is not already existing in the display file. If yes, again we display an error message segment already exists, and go to the last step. So these two checks we have to make. Check whether any of the two segments are open If so, we get a segment still open error. We check whether the new name we are going to give to old segment is not already existing in the display file. If so, we display error message like segment already exists, and we go to step number 6. Copy the old segment table entry into the new position, and then we delete the old segment and we stop like this. Delete the old segment and stop. So this way we rename the segments. Okay. So this completes the chapter segmentation. The first part took you to fundamentals of segmentation, and this second part took us to the various operations of segmentation. So these are two important parts. Part 1 is basics of segmentation, where we have seen segmentation, concept of segmentation, segment table, etc. And the second part, which took us to the different operations of segmentation and their algorithms, like creating a segment, closing a segment, deleting a segment, and renaming a segment. That's all. Thank you.